Over the last 100 years, we've completely changed the types of fat in our food, but not in a good way. We've swapped the traditional, stable fats that our ancestors thrived on, like tallow, butter, and animal fats, for industrial seed oils that never existed in the human diet before. Corn oil, soybean oil, canola, safflower, sunflower, all rich in plant-based polyunsaturated fats, PUFAs, like linoleic acid. They have flooded our food system, not just in cooking oils, chips, or salad dressings, but hidden in everything like packaged snacks, plant-based dairy alternatives, and restaurant meals. Even if you're avoiding seed oils and skipping the PUFA-rich plant-based milks like soy milk, chances are you're still consuming more PUFAs than you realize. That's because it's not just what we eat, it's what our food eats. And the modern food system has changed what they eat as well. Corn, soy, sunflower, flax, and industrial byproducts have replaced traditional feed, radically shifting the fat profile of meat, milk, and eggs relative to just a century ago. And this big fat swap isn't just changing our food, it's changing us. Fat by fat, cell by cell. Humans are not made up how they used to be. We are a lot more unsaturated. The result? Down-regulated metabolism, rising rates of obesity, food intolerances, gut problems. We're storing fat faster, burning fewer calories at rest, and moving towards a metabolic state that eerily resembles hibernation. So what happened? Let's dig into the truth about PUFAs, polyunsaturated fatty acids, and why they may be the most underrated driver of modern metabolic disease. But first, we need to understand how we got here in the first place. Before the 1900s, PUFAs made up just 1 to 2% of daily calories. Today, they make up 15 to 25%. That's a tenfold increase. And it didn't happen by accident. Government subsidies of corn and soy, industrial food production, and the demonization of saturated fat made room for mass seed oil consumption. Oils extracted with high heat and solvents that were meant originally for paint and machines, not human cells, are now produced in abundance, are super cheap, and are a hidden ingredient in most processed food. It's important to understand where these ingredients come from. Soy is a somewhat newcomer to the food system, and flax was traditionally used for making linen and industrial paints. The high PUFA content of soy and flax oxidize readily, which is great for paint hardening, but not too great for inside the human body. And now they are major parts of the food system, increasing our modern exposure to plant-based PUFAs, which we have never traditionally been exposed to in such high quantities. Here's a quote from Dr. Ray Peat. Quote, "Over 50 years ago, paints and varnishes were made of soy oil, safflower oil, and linseed, flaxseed oil. Then, chemists learned how to make paint from petroleum, which was much cheaper. As a result, the huge seed oil industry found its crop increasingly hard to sell. Around the same time, farmers were experimenting with poisons to make their pigs get fatter with less food, and they discovered that corn and soybeans served the purpose in a legal way. The crops that had been grown for the paint industry came to be used for animal food. Then, these foods made animals get fat cheaply, came to be promoted as food for humans." Dr. Ray Peat. Again, it's not just what we eat, it's what our food eats too. Pigs and chickens are now fed high PUFA diets, including soybeans and industrial byproducts like dried distiller grains. The result? Even their fat has changed. Chicken and pork used to be higher in saturated fat. But today, chicken is the #1 source of linoleic acid and omega-6 PUFA in the American diet. And pork fat, when fed high PUFA diets in confinement buildings, has the same amount of PUFAs as canola oil. So is bacon really still bacon, or is it canola infused? That's not evolution, that's manipulation. We are eating more PUFAs and less saturated fats than ever before. Now let's break down the science behind why PUFAs behave so differently than the traditional fats that we used to consume. So let's get a little nerdy, because the structure of fat tells us everything we need to know about how it behaves inside the body. Fats are made of carbon chains, and the structure of saturated fats is completely different than the structure of unsaturated fats. So it makes sense why they are broken down differently, used differently as fuel, and send very different metabolic signals to the body. Saturated fats, they're straight, sturdy fats with no double bonds, like a solid brick wall. They're stable, solid at room temperature, and resistant to oxidation. Polyunsaturated fats, PUFAs, now they are fragile and full of double bonds, which are weak spots where electrons can be easily stolen. This makes them prone to oxidation, breaking down into harmful byproducts that damage our tissues and cells. Now, these aren't just minor differences. They lead to completely different outcomes in the body. Saturated fats are burned cleanly for energy. PUFAs, they shift the body into storage mode, slowing down energy production and encouraging more fat gain. Now, it's important to keep in mind that no dietary fat is completely saturated or completely unsaturated. Every fat is a blend, but the ratio matters. And over the past century, we've completely flipped that ratio. And here's the wild part. That fat shift mimics what happens with wild animals entering hibernation. In the wild, animals don't just eat more before entering hibernation, they change what they eat. Squirrels, for example, gorge on PUFA-rich nuts before hibernating for the winter. This shift helps flip their metabolism into hibernation mode. Fat-burning enzymes ramp up, metabolism slows, and fat reserves are stacked for the cold months ahead. That's not dysfunction, it's design, a biological survival mechanism. But here's the problem. Today, humans are bathing in PUFA-rich foods all year round. Corn oil, soybean oil, canola, safflower, sunflower. And they're in everything, chips, dressings, and baked goods. And they're in the feed of livestock too, which means higher PUFA levels in meat, dairy, and eggs. So this constant PUFA exposure is rewiring our biology. We're not supposed to be in hibernation mode 24/7, but thanks to the modern food system, that's where many of us are stuck. Low energy, increased fat storage, and a sluggish metabolism. So PUFAs aren't really a poison, but they are a signal. And in excess, they're sending the wrong one. They push us toward a fat storage, energy-conserving state that closely resembles hibernation. So when you look around and see rising rates of obesity, metabolic dysfunction, and chronic disease, this isn't a mystery. It's your metabolism simply responding to the signal it's getting, loud and clear, every single day. But staying in this hibernation mode comes at a cost. So here's what happens over time. Your metabolic rate slows down, energy production takes a hit, insulin sensitivity drops, unsaturated fats build up in your body, and levels of oxidative stress and cellular damage increase. So let's dive deeper. Did you know that your body might be burning hundreds of calories less than it used to without you changing a single thing? Welcome to the silent metabolism crisis. Because it's not just about how much we eat, it's also how our bodies burn what we eat. And clearly, something's off. We're in a full-blown obesity epidemic. And metabolic dysfunction is becoming the norm, not the exception. 30.7% of US adults are overweight and 42.4% are obese, and these rates are rising. That's already nearly 7 in 10 adults, and it's not just from overeating. For decades, we've been told that obesity is a simple math problem. Eat less, move more. But what if we've been missing a critical piece to the puzzle? That the calories out side of the metabolic equation is dynamic, not static, meaning you can change it and you can increase it. Because here's a plot twist, our ancestors actually ate more than we do today, yet they were lean and metabolically healthy. So what changed? Our metabolism. It's not functioning the way it used to. Metabolic rates are dropping, meaning the issue isn't just too many calories coming in, it's also fewer calories out, fewer calories burned, and more calories stored. Metabolism is the process where your body converts food into usable energy. So what happens when this system slows down? You burn less, store more fat, and feel more tired. And you have to eat less and less just to maintain your weight, let alone lose any. A 2023 review paper led by the renowned metabolism researcher Dr. John Speakman found that total daily energy expenditure, so the calories we burn, has declined over recent decades. But it's not because we're moving less. In fact, the calories we burn through activity, called AEE, activity energy expenditure, have actually increased over the past 30 years. So what caused the drop? Dr. Speakman found that it's coming from our basal metabolic rates, BMR, the calories we burn just sitting here, staying alive. Here's a quote from Dr. John Speakman, quote, "Your resting metabolic rate now as a person living in 2023 is lower than a person of your age and body composition from the late 1990s. The magnitude of this effect is sufficient to explain the obesity epidemic." So on average, we're burning 200 to 300 fewer calories per day at rest than we used to. And what's one major reason for this? The dietary fats that we consume. In fact, Dr. Speakman pointed this out, that the changes in our dietary fat consumption, especially the shift from animal fats to industrial seed oils, may be playing a critical role. Here's another quote from Dr. John Speakman, quote, "Animal fats comprised over 90% of fat intake in 1910. Today, that number is below 15%. This shift in saturated versus unsaturated fat intake may have contributed to the decline in our basal metabolic rates," end quote. Since 1909, our exposure to plant-based PUFAs has increased 238%. And these fats, including linoleic acid and omega-6 PUFA, lower your metabolic rate, making it easier to gain weight, even if you're not eating more calories. Soybean oil, the most consumed oil in the US, has been shown to cause more obesity and more diabetes than saturated fats, yet it's labeled as, quote, heart healthy. We changed our dietary fats, and it broke our metabolisms. Now, this fat swap doesn't just impact our waistlines. It affects how much energy our cells can access, and in turn, how every system in our body performs. Now remember, at the cellular level, saturated and unsaturated fats behave very differently due to the presence of double bonds in unsaturated fats. Saturated fats, like stearic acid, move through the energy production pathway, called beta oxidation, cleanly and completely. They generate high levels of energy-carrying molecules like FADH2, which feed into the mitochondria's electron transport chain and produce a lot of ATP, the energy source for every cell in your body. This is stable, efficient, high-output energy, the kind that supports a high metabolic rate and robust cellular function. In contrast, PUFAs burn less efficiently, produce less ATP, and generate more oxidative stress and reactive oxygen species at the wrong places, which can lead to electron leakage and hinder mitochondrial function. Plus, your body uses up precious oxygen just to manage and detoxify from these unstable, unsaturated fats. But oxygen isn't something we want to waste. Oxygen is essential for oxidative phosphorylation, the final high-yield step of energy production in the mitochondria. So when PUFA overload reduces oxygen availability, your metabolic rate drops. You burn less fuel, you make less energy, and something's gotta give. Your body starts turning off non-essential functions to conserve energy. You feel more tired, digestion becomes less efficient, detox pathways back up, cognitive clarity fades, and mood can take a hit, all because your cells aren't producing enough energy to keep up. Low metabolism isn't just a diet issue, it's a fuel issue, and PUFAs are dirty fuel. And the type of fat filling your tank impacts more than just energy production. It affects how well your body can burn and utilize carbohydrates as well. Have you noticed how many people today say they just don't tolerate carbs well? But maybe it's not the carbs themselves that are the problem. Maybe it's the metabolic environment that we're eating them in. Because in a healthy metabolism with metabolic flexibility, your body knows exactly what to do after eating a mixed meal containing both carbs and fat. The body should burn the carbs first and then switch to fat burning between meals. That's by design, it's how we were built. My friend Brad Marshall from Fire in a Bottle has resurfaced a beautiful phrase from the old school medical literature that captures this concept. Quote, "Fat burns in the flame of carbohydrates." In other words, proper carbohydrate metabolism through oxidative phosphorylation actually helps your body burn fat more effectively. But that entire system starts to break down when the system is overloaded with polyunsaturated fats, PUFAs. Unlike saturated fats, which politely get out of the way and let carbohydrates burn first, PUFAs hijack this process. PUFAs burn fast and burn first. They get in the way. They enter the mitochondria first, blocking this normal carbohydrate sequence. PUFAs inhibit key enzymes that are required for proper carbohydrate metabolism, such as pyruvate dehydrogenase. The result? Instead of burning carbs for energy, your body starts storing more of them as fat. Blood sugar stays elevated longer and insulin has to work harder. And over time, this leads to insulin resistance and metabolic inflexibility, where your body struggles to switch between burning fat and carbs, which it's designed to do in normal situations. And the irony? Dietary fats that are more saturated, the ones we've been told to fear, support metabolic flexibility. They don't compete with glucose. They help your body burn it more efficiently, stabilizing energy and restoring the natural flow of energy production. This metabolic shift has wide-reaching effects. It's not just about how our body burns fuel, we're also seeing a full body transformation. Your fat tissue is different than your great-great-grandma's. more unsaturated, more oxidized, less resilient. We are basically becoming a different species. And our bodies are full of fat. Not just body fat that you can visually see, but various structures within cells, organs, tissues, and various glands rely on fat for structure and function. And here's the catch. The composition of that fat can change based on what we eat. In 1943, the average American body fat was just 10% PUFA. Today, it's 21%, with some estimates reaching above 25%. This means that the saturated to unsaturated fat ratio inside of our body has dropped by 55%, a shift that sends a powerful metabolic signal. Slow down, store energy, prepare for famine. We're entering a hibernation-like state, but in the middle of food abundance. And unfortunately, it gets worse. It's not just that we're eating more unsaturated fats, we're also making more unsaturated fats inside of our bodies. As the saturation level of dietary fats drop, the body increases the expression of lipogenic enzymes, the same ones that tell cells make more fat and store it. Some of these fats take your saturated fats inside of your body and convert them into monounsaturated fat, PUFAs, not what we want. And dietary PUFA intake upregulates these enzymes that are converting your saturated fat stores into PUFA, meaning we are losing saturated fat inside of us, a direction that we do not want to be heading. For something to go up, our unsaturated body fat stores, something else must go down. And here, that's health-promoting saturated fats like stearic acid. This is sending a strong metabolic signal, and it sets off a vicious cycle. Higher PUFA intake leads to more lipogenic gene expression, which leads to more fat stored but less saturated fat in our tissues, since that's being converted to PUFA, and this all leads to further metabolic slowdown. And the cycle repeats. And unfortunately, it doesn't stop with food. Plastics, pesticides, various endocrine disruptors, these also increase lipogenic signaling, fueling this same negative spiral. Now, this biological hibernation mode is advantageous for a mammal trying to survive a harsh winter with food scarcity. But it's a terrible state for modern humans living in food abundance. We are becoming what we eat, and our metabolism is paying the price. Let's now explore how being more unsaturated increases one of the most destructive processes in the human body, oxidation. Not all fats behave the same. PUFAs are uniquely unstable because of their multiple double bonds, and those double bonds make them highly prone to oxidation. When your fat stores are rich in PUFAs instead of saturated fats, levels of oxidative stress rise, leading to inflammation, cellular and DNA damage, accelerated aging, and a disrupted metabolism. Now, oxidation happens two ways, enzymatic and non-enzymatic. Enzymatic is driven by the activation of enzymes inside of you, which convert PUFAs into signaling molecules, many of which are inflammatory. For example, linoleic acid gets converted into arachidonic acid, which then leads to the production of 9-HODE and 13-HODE, which are oxidized linoleic acid metabolites, OXLAMs. The presence of these are strongly linked to inflammation, oxidative stress, and metabolic disease. Non-enzymatic oxidation, on the other hand, happens when PUFAs react with oxygen or free radicals. And this can happen during cooking or right inside your tissues. This process, called lipid peroxidation, creates harmful byproducts that you may have heard of, like MDA and HNE, compounds that are well documented to damage enzymes, proteins, and even your DNA. They are neurotoxic, mutagenic, and cytotoxic. These oxidized PUFA byproducts also activate inflammatory transcription factors, increasing inflammation and promoting fat storage, locking you deeper and deeper into this hibernation-like metabolic state. And the research documents that having fewer unsaturated fats inside of your body leads to lower levels of lipid peroxidation, offering protection against oxidative damage. In fact, just a 5% increase in the PUFA content of cellular structures can lead to 16 times more oxidative damage. One study found that chronic headache sufferers who lowered their linoleic acid and omega-6 PUFA intake from 6.74 to 2.42% of daily calories over 12 weeks not only reduced their linoleic acid byproducts, but also saw dramatic improvements in headache severity and the quality of life. Now, that's real-world evidence that reducing your linoleic acid intake can help reduce inflammation and oxidative stress. Saturated fats, by contrast, lack these double bonds that make PUFAs so unstable. They're far more resistant to oxidation during cooking, digestion, and inside the body, supporting better metabolic health and lowering inflammation. PUFAs send powerful signals, but they're not the signals that we want. They're signals for storage and downregulation of metabolism. They're great for squirrels in the fall and winter getting ready to hibernate, but they're not so great for humans trying to thrive. This isn't just theory, it's visible. Today's humans are more fatigued, more inflamed, carrying more unsaturated fat and less saturated fat, are burning fewer calories at rest and are storing more fat, are producing less energy, which slows down vital processes throughout the body. And even breast milk reflects this dietary fat shift. Research shows that mothers produce milk with higher levels of unsaturated fats relative to saturated fats compared to just a few generations ago. And this is because the diet of a mother directly reflects the types of fat that show up in her milk. So we are literally reshaping the next generation from birth. And each generation seems to enter the world with a metabolism already tuned slightly down, drifting closer and closer to this hibernation-like state. So, what can we do about it? Let's break it down. The type of fat you eat doesn't just influence the type of fat you store. It also shapes your basal metabolic rate, your energy levels, and whether your body operates in a state of burning or storing. Due to drastic changes in the modern food system, the average intake of plant-based PUFAs, especially linoleic acid, is exponentially higher than at any other point in human history. Our ancestors didn't eat this way. They thrived on diets rich in traditional fats that were more saturated and supported higher metabolic rates, better energy production, and an easier time maintaining a healthy body weight. The rise of dietary PUFAs is one of the most overlooked drivers of our declining metabolic rates and the modern metabolic health crisis. Higher PUFA intakes sets off a chain reaction that pushes us closer to a hibernation-like metabolic state. It downregulates metabolism, suppresses energy production, increases oxidative stress, promotes fat storage, and leads to rising levels of unsaturated fats in our tissues. PUFAs are reshaping the human body from the inside out. But there's good news. You can change that direction. Your biology adapts to the signals you send it. And the solution is simple. Return to what our ancestors knew all along. Ditch industrial seed oils like corn oil, soybean oil, canola, sunflower, safflower, and grapeseed oil. Cook with traditional fats like butter, tallow, ghee, and coconut oil. Minimize packaged foods, plant-based milks, and snacks made with PUFA-rich oils. Limit PUFA-rich nuts and seeds. Choose fats with a favorable saturated to unsaturated fat ratio, such as quality chocolate and dairy fats. Opt for pasture-raised meats, dairy, and eggs. And when you can, go corn and soy-free for chicken and pork products. And if that's not accessible, choose leaner cuts for chicken and pork products to reduce your PUFA exposure. Now, this is a long game. It took decades for our food system and our bodies to get this far off track. Restoring metabolic health takes time, patience, and consistency. But every single meal is a message. Every fat you eat is a signal, and every signal shapes your biology. You're not just changing your diet, you're changing your body, cell by cell, fat by fat. The evolution of PUFA consumption has fueled the de-evolution of human metabolism. But you can opt out. Change the signals. Reclaim your biology, reclaim your food, reclaim your energy. Become more saturated. At Nourish Food Club, we created the low P's standard to bring real food back to its roots through traditional regenerative farming and custom low PUFA diets for our livestock. By significantly reducing 3 P's, polyunsaturated fats, pesticides, and phytoestrogens, 3 metabolic disruptors saturating our food supply, we can restore the integrity of our food system from the ground up. Our food sends clear metabolic signals that support energy, not storage, that favor saturation, not oxidation, that bring the body back into balance. This is real food you can trust. Reclaim your biology one bite at a time.